Namaste my dear students, Nenu Mi Suryateja from Saimedha Ecet Coaching Center Koti, Hyderabad. Director JC Sir ఆధ్వర్యంలో శశికాంత్ వాల్మీకి సార్ పర్యవేక్షణ నిర్వహిస్తున్న సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఈసెట్ 2023 రాసిన విద్యార్థులందరికీ మీరు అబ్జెక్షన్స్ పెట్టుకోనికి వీలుగా ఉండాలి అనే ఉద్దేశంతో ఈసెట్ పేపర్స్ అన్నిటిని బిట్ టు బిట్ ఎక్స్ప్లెయిన్ చేయడానికి ఈ వీడియో లెక్చర్ సిరీస్ మీ ముందుకు తీసుకురావడం జరిగింది. కాబట్టి మై డియర్ స్టూడెంట్స్, ఎవరైతే ఈసెట్ 2023 రాస్తారో, ఎవరైతే క్వశ్చన్స్కి ఆన్సర్స్ తెలుసుకోవాలనుకుంటున్నారో, పూర్తి డీటెయిల్ ఎక్స్ప్లెనేషన్ ఈ వీడియో లెక్చర్స్ని ఖచ్చితంగా వాచ్ చేయండి. అలాగే మీ ఫ్రెండ్స్ అందరికీ కూడా ఈ వీడియో లెక్చర్ సిరీస్ని షేర్ చేయండి. దీంతో పాటుగా మై డియర్ స్టూడెంట్స్, ఎవరైతే ఈసెట్ 2023 రాస్తారో వీళ్ళందరికీ సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఒక ద్రోణాచార్య బ్యాచ్ ని ఇంట్రడ్యూస్ చేసింది. గత 25 సంవత్సరాలుగా ఎంతో మంది ఇంజనీర్లు తయారు చేసిన సంస్థ సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ డిప్లొమా విద్యార్థులకి అండగా బాసటగా నిలవన ఉద్దేశంతో ఈ బ్యాచ్ ని మీ ముందుకు తీసుకురావడం జరిగింది. ఈ బ్యాచ్ లో భాగంగా మీ అందరికీ మొదటిగా మీరు బీటెక్ లోకి వెళ్ళిన వెంటనే ఇబ్బంది పడుతారు అనే ఉద్దేశంతో, ఆ ఇబ్బందిని పోగొడితేనే ఫ్రీ మైండ్ తో ఉంటేనే పని బాగా చేస్తారనే ఉద్దేశంతో బీటెక్ 2-1 అకాడమిక్ సబ్జెక్ట్స్ ని ప్రొవైడ్ చేస్తున్నాం. బీటెక్ 2-1 అకాడమిక్ సబ్జెక్ట్సే కాకుండా సిఆర్టీ క్యాంపస్ రిక్రూట్మెంట్ ట్రైనింగ్, దీనిలో భాగంగా ఆప్టిట్యూడ్, రీజనింగ్, ఇంగ్లీష్, అదేవిధంగా సిఆర్టీకి కావాల్సిన బేసిక్ కోడింగ్ లాంగ్వేజెస్ సి కావచ్చు, C++ కావచ్చు, జావా కావచ్చు, పైథాన్ కావచ్చు, వీటన్నిటిని మనము లైవ్ క్లాసెస్ ద్వారా అందిస్తాం. దీంతో పాటుగా థర్డ్ వన్ డిప్లొమా బేస్డ్ జాబ్స్ టెస్ట్ సిరీస్, మీరందరూ సంవత్సరం నుంచి కావచ్చు, సెకండ్ ఇయర్ కంప్లీట్ అయిన దగ్గర కావచ్చు, ఫస్ట్ ఇయర్ కంప్లీట్ అయిన దగ్గర కావచ్చు, ఈ సెట్ కొరకు ఇంజనీరింగ్ సబ్జెక్ట్స్ బాగా ప్రిపేర్ అయ్యారు. ఇదే ఇంజనీరింగ్ సబ్జెక్ట్స్ అనేది మీకు రేపు డిప్లొమా బేస్డ్ జాబ్స్ కూడా ఉండడం జరుగుతుంది. కాకపోతే మీరు రేపు జాబ్ పడినప్పుడు రెడీగా ఉండాలంటే కన్సిస్టెంట్గా ప్రిపరేషన్ అది అవసరం అవడం జరుగుతుంది. కన్సిస్టెంట్గా మీరు ఆల్రెడీ మీ అందరూ బాగా ప్రిపేర్ అయ్యారు, మీకు సపోర్ట్ ఉండాలనే ఉద్దేశంతో ఒక టెస్ట్ సిరీస్ కూడా మనం ద్రోణాచార్య బ్యాచ్లో ఇంక్లూడ్ చేయడం జరిగింది. ఈ టెస్ట్ సిరీస్లో భాగంగా ప్రతి వీక్ టాపిక్ వైజ్ గ్రాండ్ టెస్ట్లు కండక్ట్ చేస్తాం. టాపిక్ వైజ్ అయిపోయిన తర్వాత మనం మిక్స్డ్ టాపిక్స్ ఆర్ మిక్స్డ్ సబ్జెక్ట్స్ గ్రాండ్ టెస్ట్ కండక్ట్ చేస్తాం. ఫైనల్ గా ఓవరాల్ గ్రాండ్ టెస్ట్లు కండక్ట్ చేయడం జరుగుతుంది. 1 ఇయర్ పాటుగా మీకు ఈ డిప్లొమా బేస్డ్ జాబ్స్ యొక్క టెస్ట్ సిరీస్ కోర్స్ అందించడం జరుగుతుంది. దీంతో పాటుగా 2 ఇయర్స్ వ్యాలిడిటీతో ఆల్ ఓవర్ ఇండియాలో ఎవరు తయారు చేయలేని విధంగా మన సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఒక గేట్ కోర్స్ని రెడీ చేయడం జరిగింది. ఆ గేట్ కోర్స్ విత్ వ్యాలిడిటీ ఆఫ్ 2 ఇయర్స్ అందించడం జరుగుతుంది. ఈ 4 మాడ్యూల్స్ మనము ద్రోణాచార్య బ్యాచ్లో అందించడం జరుగుతుంది. దీని విలువ సుమారుగా ₹1,00,000. కానీ ఈ కోర్సు మొత్తాన్ని ఫ్రీ ఆఫ్ కాస్ట్గా అందించడం జరుగుతుంది. జస్ట్ ఈ 2 సంవత్సరాల మెయింటెనెన్స్కి, అదేవిధంగా టెస్ట్ సిరీస్ కోసమని రిజిస్ట్రేషన్ ఫీజ్ ₹3,000 అనేది తీసుకోవడం జరుగుతుంది. ఎవరైతే డిప్లొమా కంప్లీట్ చేసుకుని బీటెక్ వెళ్తున్నారో వీళ్ళందరికీ ఒక మంచి అవకాశం ఇది. కాబట్టి ఈ అవకాశాన్ని మీరందరూ ఉపయోగించుకుంటారని ఆశిస్తున్నా. మీరు ఈ అవకాశాన్ని వినియోగించుకోవాలంటే ముందుగా మీరు మన అప్లికేషన్ స్పేస్ గేట్ అనే అప్లికేషన్ని డౌన్లోడ్ చేయండి. డౌన్లోడ్ చేసిన తర్వాత అందులో ప్రొఫైల్ సెక్షన్ ఉంటుంది. ఆ ప్రొఫైల్ సెక్షన్ మొత్తాన్ని ఫిల్ చేయండి. ఫిల్ చేసిన తర్వాత మీ అడ్మిషన్ ప్రాసెస్ కోసమని 9848692598 ఈ నెంబర్కి కాంటాక్ట్ అవ్వండి. అడ్మిషన్ ప్రాసెస్ ఎట్లా, అదేవిధంగా ఇంకేమైనా కోర్స్ డీటెయిల్స్ ఏమైనా కావాలంటే కూడా పూర్తి ఇన్ఫర్మేషన్ అందించడం జరుగుతుంది. మై డియర్ స్టూడెంట్స్, మీరందరూ ఈ అవకాశాన్ని వినియోగించుకుంటారని ఆశిస్తూ నేను మీ సూర్యతేజ ఫ్రమ్ సాయిమేధ ఈసెట్ కోచింగ్ సెంటర్ కోటి హైదరాబాద్.
Let's start from the question number 12th question. The question is, the fall in the speed of the DC generator due to increase in the load can be corrected by, so option 1, cooling the armature, increasing the excitation, reducing the load voltage, increasing the input of the prime mover. The speed of the DC generator can be adjusted by adjusting the mechanical input of the generator. That means by adjusting the input of the prime mover. So option 4 is correct for this question. And next question number 113, the 113th question. A 4-pole 25 kilowatts 200 volts wave wound separately excited generator the current in each parallel path will be option 1 62.5 amps and option 2 125 amps, option 3 31.25 amps, option 4 250 amps. So this one is a output of the generators and terminal voltage the VT. So output is given, output power of the generator the is equal to 25 kilowatts. Okay, this 25 kilowatts, and the terminal voltage the VT is equal to 200 volts. And how do we get the current? The current armature current. So it is also load current but it is a separately excited current. This IA is equal to IL. So that is equal to output power of the generator the divided by the terminal voltage of the generator. So this output power is equal to 25 the into 10 to the power of 3 divided by, so this is divided by terminal voltage the 200. So it is equal to 125 amps. Now we require the current in the each parallel path. The given winding, the wave winding, so that the number of the poles is equal to 4 number of the poles, but number of the parallel paths in the wave winding is equal to the 2 number of the parallel paths. Now we require current in the each parallel path. So current the in the each parallel path of the parallel path of armature winding, so that is equal to IA by A. So this how many number of parallel paths in the wave connected armature winding? The 2 number of the parallel paths. So it is a 125 divided by 2, it is equal to 62.5 amps. So answer for this question option 1 is correct. Got it? Next, the question number 114. The direction of rotation of the DC shunt motor can be reversed by reversing the supply terminal and the field terminals, armature terminals, either field or armature terminal. So DC shunt motor is given. So this in the DC shunt motor, suppose assume this one is the armature. So now field winding is connected across the armature winding. So it is the RSH and armature resistance RA, and this one is a supply voltage. The V is a supply voltage. The torque produced in the machine directly proportional to the field flux and armature current. Okay, so if I change the supply terminal, what will happen? This current will be changed. This is the current, armature current, and the field flux, it is a phi F. Okay, field flux one. So now if supply terminals are reversed, then what will happen? Flux will be reversed and also armature current will be reversed. So if the supply, the voltage terminals are reversed, then what will happen? The terminals are reversed. So then the torque directly proportional to minus pi F minus IA. So now same we will get, the torque is directly proportional to phi. Suppose if it is a clockwise, this is also will become clockwise. So instead of changing the supply voltage, if I change the field winding terminal, so flux will become reverse, and if I change the armature winding terminal, armature current will become reverse. So in order to change the direction of the DC shunt motor can be reversed by reversing the either field winding terminals or armature winding terminal, but not both, or but not supply voltage terminals. So that option 4 is correct for this question. And next, question number 115. The efficiency of the DC motor when developed, when the developing maximum power will be about 100%, the 50%, less than 50%, more than the 50%. So condition to get the condition to get the maximum power developed, okay, in the DC machine, maximum power developed so that is equal to, so this one is a EB is equal to the supply voltage the divided by 2. So but we required the maximum efficiency, the percentage efficiency of, it's not maximum efficiency, percentage efficiency of the motor, the at maximum power developed condition, P maximum developed condition. So we know efficiency of the machine. So we know that the efficiency the is equal to ratio of output power to the input power. Okay. So this output power we can write the EB multiplied by IA, and this is the V multiplied by IA into 100. So IA will be cancelled out. So this is equal to the EB into V multiplied by 100. So we require the efficiency of the motor at maximum power developed condition. So percentage efficiency of the motor the at maximum the power developed condition, P maximum the conditions. So that is equal to, so what is the value of EB at a condition to get the maximum power developed? So here V by 2 divided by the V into 100. So V will be cancelled out. So this is equal to 50%. So answer for this question, option 2 is correct for this question, 50%. And next question number 116, a DC shunt machine connected to the 250 volts mains as its armature resistance 0.12 ohms, field resistance of 50 ohms. Find the ratio of the speed of the generator to the speed of the motor, the line current of each, the line current in each case being 80 amps. Option 1 2.024, option 2 1.079 and 1.982, option 4 0.623. Okay, and initially this is the supply voltage connected to the voltage DC shunt machine, and given data in this question, the given data, so DC shunt machine and the voltage, terminal voltage VT is equal to the 250 volts, and armature resistance RA is equal to 0.12 ohms, and field resistance the RSS, shunt field resistance, is equal to the 50 amps. Okay, this one is the 50 ohms, and we need to find out the speed of the generator divided by speed of the motor. So this ratio is required. So let us calculate initially shunt field current. So how do we calculate the shunt field current? ISH is equal to the VT by RSH value. So what is the value of VT? The VT is the 250 volts divided by 50, the equal to 5 amps. So this is the shunt field current. The when machine act as a generator, the when machine the act as generator, so then what will happen? So when machine is act as a generator, armature current IA is equal to the ISH, okay, plus the IL, okay, load current. So what is the value of ISH? ISH is equal to 5 amps and I is equal to 80 amps. This is the IL is equal to 80. So now here the 80, it is equal to 85 amps. Now we know IA, so that we can find out the generated voltage EZ. The EZ is equal to VT plus IA RA value. So VZ is equal to, so VT, so value this one, the VT is a 220, this one is a 250, the plus, okay, IA value is equal to, so IA is this 85, armature resistance RA is equal to 0.12 ohms. Okay, this is the generated voltage. Now when the machine is act as a motor, then what will happen? So when the machine the act as a motor, so this one is a IA is equal to I minus, okay, this ISH value. So this when machine is act as a motor, so armature current IA is equal to 80 minus 5, so this is equal to 75. So now therefore back EMF of the motor EB is equal to the minus V minus the VT minus IA RA. So VT is equal to 250 minus IA is equal to 75 the multiplied by 0.12 ohms okay, armature resistance. Now we know the speed of the machine is a directly proportional to okay, this is a speed of the machine is a directly proportional to the generated voltage in the armature the divided by the field flux. So in the shunt motor flux is a constant okay, flux is constant. So why? Because supply is constant, so that flux is also remain same. So therefore the speed is directly proportional to here. The speed of the generator divided by speed of the motor the is equal to the generated EMF divided by the back EMF of the motor. So now Ng by Nm, so it is equal to so 250 the plus the 85 the into 0.12 divided by the 250 minus okay, 75 into 0.12. So by solving this okay, here, so we will get the speed of the generator divided by speed of the motor is equal to 1.079. So by solving this equation, so we will get the speed of the generator divided by the speed of the motor 1.079. Option the 2 is correct for this question. And next one, the question number 117. The effect of armature reaction in the DC machine can be reduced by using dash the commutating poles and compensating winding. Option 3 commutating poles and compensating winding, and option 4 damper winding. Commutating poles is also called the interpoles. The armature reaction in the DC machine can be neutralized by mainly by using the two methods. One is by using the compensating winding and also by using interpoles. So that answer for this question, the commutating poles and the compensating winding. So option 3 is correct for this question. And next question number 118. The question is the output of the DC motor that depends mainly on the speed and torque, the speed and applied voltage, the speed and back EMF, and torque and applied voltage. So power developed in the any electrical machine or power that developed in the any electrical machine, so is equal to the 2 pi nt by the 60. So where n is the speed of the motor, so this one is a speed and the t is a torque developed in the motor. So this output power of the DC motor depends on the speed and the torque of the motor. So that option 1 is correct for this question. And next one, question number 119. The question is the speed of the DC motor is the directly proportional to the field flux, inversely proportional to the applied voltage, directly proportional to the applied voltage, and inversely proportional to the field flux. And option 4 inversely proportional to the product of applied voltage and the field flux. So we know the back EMF of the motor, the EB is equal to the phi Zn by 60 the into P by A. So in this equation, number of conductors, number of the poles, and number of the parallel paths are fixed at the time of the designing and treated as a constant during operation. So that during operation of the motor, okay, this operation, so this back EMF directly proportional to, so this directly proportional to product of the field flux and the speed of the motors. So this is only valid during operation. So from this equation you can get the speed of the motor is a directly proportional to the back EMF and inversely proportional to the field flux. So now this back EMF is, we know what is the back EMF value? So where back EMF EB is equal to V minus IA RA. So if drops is a very small as compared to the back EMF. So back EMF is directly proportional to applied voltage. So that this is directly proportional to applied voltage and inversely proportional to the field flux. So answer is directly proportional to the applied voltage and inversely proportional to the field flux. So option 3 is correct for this question. Got it? And next question number the 120. The question is the transformer action requires constant magnetic flux, the increasing magnetic flux and alternative magnetic flux, alternating electric flux. The flux in the transformer is a time varying nature of the flux. Now that is a phi maximum the sin omega t. So it is the alternative magnetic flux. Okay. So this nature of the flux in the transformer is a time varying nature of the flux or alternative magnetic flux, but its magnitude is independent of the load current or load variation. So answer for this question alternative magnetic flux is the right answer. So next one, question number 121. The question is a 220 upon 440 volts 50 Hz pi kVA single phase transformer operates on 220 volts 50 Hz supply. Then so option 1, eddy current loss increases, hysteresis loss increases. Eddy current loss decreases, hysteresis loss increases. Option 3, eddy current loss increases and hysteresis loss decreases. Option 4, eddy current loss decreases, the hysteresis loss the decreases. Got it? And so in this assume here the excitation given that, okay, here it is not mentioned that let assume the excitation that is given, the excitation of the machine, okay, excitation of the transformer is a high voltage side of the transformer. So otherwise the these options are not matching. So that assume. So that means initially the 440 50 Hz. So under this condition we have some hysteresis loss and eddy current losses. Now same transformer is operated at the 220 volts and the 220 volts. So another one is a 220 volt 440 and this is the 50 Hz or 40 Hz supply. So under this condition what will happen in the eddy current? So we have taken just first case one, the excitation is given to the high voltage side of the transformer. So when high voltage side is given, so let us verify the flux density, verify the flux density of the transformer core, okay, B maximum. So B maximum is directly proportional to V1 by the F ratio. So therefore the B maximum 2 is equal to B maximum 1. So multiplied by the V12 divided by V11, the F1 divided by the F2 values. So B maximum 2 is equal to B maximum 1 the into applied voltage, okay, 220 the upon 440, okay, this 440 the frequency F1 is equal to 50 Hz and divided by, okay, 40 Hz. Now this is also B maximum 2 is not equal to the B maximum 1. So B maximum 2 is not equal to B maximum 1 in this condition. When B maximum is not constant, suppose when the B maximum, okay, is not constant, okay, not constant, so what will happen? The hysteresis loss directly proportional to, okay, V1 power 1.6 and F power 0.6 and eddy current loss directly proportional to the V1 square. Now suppose if I take the excitation, assume the excitation is a, okay, this excitation is of the transformer, the rated LV side. The LV side means 220 the 50 Hz, okay, divided by 220 the 40 Hz condition. So here also flux density is not constant, B maximum is not constant. When the B maximum is not constant, these are the formulas. So when B maximum is not constant, then what will happen? The hysteresis loss directly proportional to V1 power 1.6 F power 0.6 and eddy current loss directly proportional to the V1 square. So in this case given, so suppose if I take this condition, okay, this condition here, so now what will happen? Keeping the voltage constant, the frequency is a decrease, the hysteresis losses will be increased. Now what about this is the eddy current losses? This is the applied voltage is a constant. Okay, now eddy current losses is also constant. So eddy current loss is a constant and hysteresis losses will be increased. So let us verify the option. Eddy current loss increases, hysteresis loss increases, eddy current loss decreases, hysteresis loss increase, eddy current loss increases and hysteresis loss decreases, and eddy current loss decreases, hysteresis loss decreases. So here no option is no options that is matching, so that you can object this question. So now this one is a no options are matching for this question. So objection. So you can do the objection for this type question number 121. No options are matching here. So exactly answer is the eddy current loss. Okay, hysteresis loss will be increased and eddy current losses is a constant. This is the answer for this question. So answer is the hysteresis loss increases and eddy current loss is a constant. Got it?
The reactance offered by a capacitor to AC of frequency 50 Hz is what? 10 ohms. If the frequency is increased to 100 Hz, the reactance becomes. Look at here. We know that capacitor reactance, what is that? Tell me. Capacitor reactance XC is equal to 1 by omega C, or XC is equal to 1 by 2 by FC, like this. So if you see that reactance is talking about reactance, okay, right? Reactance offered by the capacitor to a particular frequency, then next frequency is given, then what will be the reactance? If you see that capacitor reactance is inversely proportional to the what? Frequency F, right or not? So here XC1 by XC2 is equal to F2 by what? F1, because frequency is only given. What is XC1 here? Reactance is 10. XC2 we need to find. F2 is how much here? 100 Hz, and F1 is how much here? 50. Simplify 2 times and 2 5s. So capacitor reactance becomes what? 5 ohms when frequency increases. Definitely decreases, right? It is doubled, means it becomes half, because it is inversely related to the what? Frequency. If it is inductive reactance, what you can comment? Inductive reactance means inductive reactance XL is equal to omega L, XL is equal to 2 by FL. So here it is directly proportional to the frequency. If it is increases, here also increases. If it is inductor, what? Capacitor means inversely related. So this will be the what? Result, and which is available in our option.